Hello everyone. Today we're going to be going over an AMC 12 problem, problem 19 on the AMC 12B. And why we're going over this problem is because it really emphasizes how the use of slightly advanced knowledge can get you through a problem that would otherwise be a hassle. If you look on the AOPS forums, the solutions to this problem are kind of long. I'm going to be honest, this is quite a bashy solution. And so what we really want to do here is use knowledge of cyclic quadrilaterals, which you can see covered on a CNCM lecture. So what does this say? In ABC, C is 90, AB is 12, and there's two squares on its sides, and we're trying to find something. And it says points X, Y, Z, W, line a circle. And so we're just going to draw this out. What is this saying? Well, this is saying it's not the right thing to be using for this. It says ABC is a triangle. This is 12 ABC, and it says that this is a square. This is a square, and that this is a cyclic quadrilateral. That's what the question says, and it says I'm supposed to find the perimeter of ABC. And we know this is cyclic, so we can draw a circle. I'm not going to keep the circle there, but this is the circle. It looks something like this. I'm not going to keep that circle. So what most of the solutions do is quite obnoxious, honestly. But what we're going to do here is we're just going to use the first basic theorem of cyclic quadrilaterals. And it absolutely kills this case because we know that this angle and this angle have to add up to 180 degrees, and you can already see these two triangles look similar. The only two triangles, or two of three triangles in the photos look similar, but we can show this quite easily. This is, let's call this theta. This is called as alpha, right? Then I'm going to redraw that in that line. Then this angle, which is 90 plus theta, plus this angle, which is 90 minus alpha, have to add up to 180. And clearly this just means that this is theta. This is theta. We have the same angle. And this sort of confirms our suspicions that these triangles are similar. Similarly, this is what, 90 plus whatever. We can call this like alpha. Because this is a right triangle. Remember, this is a right triangle. And this is what, 90 minus alpha. Well, you could say 90 minus theta, but the point is these are the same angles as well. So we have similar triangles. This is just by using the first theorem of cyclic quadrilaterals, which I will remind you that the other solutions did not use, and the other solutions were like really long. And so we have similar triangles, and so we're just going to use basic cyclic or basic similar triangles idea. So we're going to just make ratios out of this triangle and then over this triangle. So let's talk about the side opposite alpha. Side opposite alpha in this triangle is 12. So we have 12 over the side opposite alpha here, which is, what is this? Well, this is the height of the triangle. We're gonna have to introduce some variables, but the idea is the opposite thing opposite alpha here is 12. Thing opposite alpha here is h. So 12 over h equals what's the thing opposite theta? Here it's gonna be h plus w over what's the thing opposite theta here? This is 12. This means 144 equals h squared plus hw. But you know what else 144 equals? This is a right triangle, which means 144 equals h squared plus w squared. You subtract these two things, it gives you hw equals w squared, h equals w. This is a right triangle. This is 12 over root 2. This is 12 over root 2. We just get this by 45, 45, 90 degree angles, because this is isosceles because h equals w. And we're trying to find the perimeter. So this is just 12 over root 2 plus 12 over root 2 plus 12 equals, what is this? Well, this is 12 root 2 plus 12, which happens to be one of the answer choices. And this is why you need to use cyclic quadrilateral theorems and learn these theorems. And I really encourage you to just watch that lecture of ours and watch every lecture of ours, because you'll get a lot of interesting concepts that you can just apply, and you'll be able to solve problems like these in 2 minutes. Thank you, and that'll be all.